Start with a striking fact: most enterprise GPUs sit idle over 70% of the time, wasting millions.
By the end of this lesson, you will evaluate GPU capacity strategies. You will analyze utilization patterns, scaling constraints, and cost trade-offs.
Most enterprise GPUs sit idle over 70% of the time. That is massive waste. Utilization efficiency measures actual compute time against total available time. Low numbers come from idle periods and job queuing. You pay for the hardware either way. Fixing utilization is your fastest path to lower costs. Utilization efficiency is the ratio of actual GPU compute time to total available time, often below 30% in enterprise settings due to idle periods and job queuing. This forms the foundation for everything else we'll discuss. Without a firm grasp of utilization efficiency, the downstream steps don't hold together. You have profiled your workloads. Now you need to understand the bottlenecks. GPU memory limits batch sizes. NVLink bandwidth between GPUs can stall distributed training. A single job might show 90% utilization, but memory pressure forces smaller batches. That kills throughput. Workload profiling reveals these constraints across training, inference, and preprocessing. Here is where the real capacity planning begins.
A mid-size enterprise runs 10 training jobs daily. Each job uses 100 GPUs for 2 hours. That is 80 GPU hours. Inference runs continuously on 2 GPUs, adding 48 GPU hours. Total used is 128 GPU hours. Total available is 144 GPU hours. Utilization is 88.9%. This is high, but it leaves no room for spikes. Elastic capacity would absorb overflow without over-provisioning reserved GPUs. Present the large enterprise case: 500 GPUs at 28% utilization, 360 idle GPU days per day. So now you see why utilization efficiency is the real metric. Most enterprises waste 70% of their GPU spend. Elastic capacity buys you flexibility. Reserved capacity cuts costs for predictable loads. Profile your workloads first.
Encourage the viewer to open their GPU utilization dashboard, AWS CloudWatch GPU Metrics or Azure Monitor, and spend 20 minutes analyzing their own usage patterns to identify savings opportunities.